Last video I played a game where I win $5 when I hit a crossbar with probability 20%, and I lose $1 when I miss the crossbar with probability 80%. Now consider a different game where the object is to make a three-pointer with a basketball. Like I did with the soccer ball, I take a bunch of shots over and over to try to figure out what's my probability of making a three-pointer. In the end, I estimate that the probability I make a three-point shot is about 1 in 10, or 10%. Now let's say someone offers me a game like the one with the soccer ball, except this time when I make a shot, I win $10. When I miss a shot, I still lose $1. So the question is, which game should I play to win the most money? Well, keep in mind that even though I win more money for making a shot with the basketball, my probability of success with the basketball is lower. So to figure this out, we're going to need to understand the expected value of both games. Remember the expected value? The average value we expect a random variable to take on in the long run? Here we've mapped out the expected values for both games. Money won from successes, money lost from misses, and the combination of the two. We've also created two rows, one for expected value over 10 attempts, and one for expected value on 1 attempt. Now I challenge you to pause your video and really try to fill out the table for yourself for the soccer game. Okay, I'll give you a quick hint, okay? So for these 4 boxes, you're trying to calculate the expected money won or lost from successes or failures over those attempts. So like for the upper left-hand corner, take the money that you expect to win per success and multiply it by the number of successes you expect, which you get by multiplying the number of attempts times the probability of success. And just do that to get all 4. And then add up across the rows to get your totals. Okay, now pause your video and go solve these. Okay, are you ready? We expect 10 times 20%, or 2 successes, so we expect to win $10 from hitting the crossbar. And we expect to miss 8 times, so we expect to lose $8, and that gets us $2 total over 10 attempts. Over 1 attempt, it's really the same process, but everything is divided by 10, so instead of 2 successes, you expect 0.2 successes, which gets you $1, and so on until you get 20 cents expected total. If you want to see that hypothetical 10 attempts play out, just go check out the previous video. And now that you're experienced calculating expected value, try it again for the basketball game. Pause your video and try to fill out these 6 boxes. Seriously, pause your video. Okay, and just for fun, before I reveal the answers, let's look at what we would expect those 10 attempts at the basketball game hypothetically to look like. Yeah, I'm really bad at that. Anyway, you can see from the video that we expect 1 success to win me $10 and 9 failures to lose me $9 for a total of $1 over 10 attempts. For 1 attempt, same idea, just divide by 10. So $1 expected in winnings, 90 cents in losses, and a total of 10 cents expected. So if we compare the total expected values of both games, we can see that although both games have positive expected values, I would still expect to earn double playing the soccer game over the long run. So I'm going to stick with the soccer game, which is fine by me because I'm really bad at the other game.